Good afternoon. I am Ashwini Mhatre. I am working for Cisco Systems in Bangalore. I have experience in building different use cases in OpenDaylight. Like I have implemented service plugin using OpenDaylight REST APIs in Neutron side. I have also created some apps which can capture the packets and display some statistics about that packets. So it's basically some video traffic as well as the normal traffic. So being OpenDaylight user from hydrogen to boron release, I found that there is a huge evaluation for each project, because in OpenDaylight we have a different projects. So for each project they have evolved, they have add more features. But if we consider DLUX, we don't have that much features there in DLUX. And the same concern is raised by the core DLUX developer in last summit. So basically for any product which have a UI, so basically UI is a key point through which the user can get that product very well. So main area of this my presentation is in next 20 minutes I will talk about the one use case which will add some dynamic features inside DLUX, and then I will cover some future scope of that product, that use case. So if you have any question, please hold on, we will take it after this session. So basically these are the certain features which are already there in DLUX. So if we connect any network with our SDN with our ODL, so for example, if you create mininet topology and then you can connect it with the OpenDaylight, you can see that network topology inside DLUX. Again, you can see the statistics of different network element inside DLUX. Again, you have a capability in DLUX through which you can see the topology in the YANG UI. So what basically this alert mechanism is, in this alert mechanism, user can see the status of particular network traffic, and again user can capture the alerts based on different traffic measures. For example, if there is a congestion in traffic or if there is a jitter in traffic, user can see that through DLUX itself. So for example, green color indicate if there is a normal traffic flow, red color indicate if there is a congested traffic or jitter in traffic. So let's see workflow of this use case. So first step of this use case is we have to write one application inside controller. So this application act as an alert provider for our use case. So second block is we have to implement app in a such a way that it will send alerts to the DLUX. So based on that alerts, in DLUX code we can monitor that alerts, and we can display that alerts through our DLUX. So the first two phases are basically deal with the backend code, and the last two phases are basically deals with the our this UI side code. So now we'll see this implementation in detail. Yeah. So basically in first step, we have to write application inside DLUX, inside OpenDaylight controller. So what we can do is we can use the MDSL architecture. We can write the YANG model, and in that we can use the existing API. So for example, here in my use case, I am using network topology API for adding the alert info. So in second step, the API gets ready. So I have the API which has the alert information. I will monitor that API. So basically for getting this alert information, we can use the packeting event. So based on this event we can capture. So for example, I have tested for the RTP packets. So for any RTP packet, we have a RTCP packet which gets the control information. So if we decode that RTCP packet, we have there some information like we have a inter-arrival jitter. So we can consume that jitter information as our measure, and then we can add it into our topology API, and we can then monitor that API inside DLUX code, and then for each condition we can keep the color code. So for example, if I am considering congestion and a jitter as a traffic parameter, so if I get jitter as a 0 and congestion as a 0, that means it's a idle condition. So for idle condition, the traffic color will be normal, green, and for if we have a 0, 1, 1, 0 or 1, 1, for this condition the traffic color flow will be red. Yeah, so now we will see this implementation in detail. So as I considering everyone is now aware of how to write application inside MDSL. So for this alert provider, we can create our own application, or we can add the feature inside L2 switch. So now I am considering here adding the feature inside L2 switch. So you can see here we have already existing some features in the L2 switch. You can see here I am adding alert provider as a new feature. We can see the directory structure of a alert provider. So as you already know that we have a model implementation and config subsystem. Yeah, so this is basically pom.yaml file in which this is for a feature. So you can see the modules which are defined there. So we have a model implementation and config, and it will be a part of a L2 switch. So it will point to the parent form of a L2 switch. Yeah. So this is basically our API design. So as I said, we are using the Yang modeling language. So you can see here, I'm using some different structures here. For example, I'm using grouping. So you already aware that grouping, by using grouping, it's kind of a structure in C. So we can create our own data structure here. So this alert is our new data structure, and in alert we have the list of alerts, which is nothing but the congestion in traffic and jitter in traffic. So these two things I have defined here, and I'm using here argument. So what basically argument do is, we are using the network topology API, which is an existing API. So we're gonna extend that API, and we just add this alert information into that API. So we consider the link. So for each link we are adding the alert information, and then we are going to monitor this link information inside our DLUX code. Yeah, so this is a REST API which is already there, topology REST API. So we get the all information, operational information of a topology in this API. So you can see here this for each link. So link is a node, and for each link we are attaching alert information. So you can see here this is the idle condition which I am talking about. So 0, 0, that means we don't have any congestion or a jitter. So for this information, the color code will be green. So it's the idle condition for our use case. Yeah. So this is a non-idle condition. So this is the first non-idle condition where we have a congestion in traffic. This is the second one which indicates we have a jitter in traffic. And this is again we have a both in traffic. So this all conditions we are indicated by the red color. Okay, so basically now I will show you how this actual implementation will look into the DLUX. So you can see here we have a two tabs, that is a normal traffic and the congested traffic. So user is easily get to know that there is a normal traffic flow for this my network traffic. And again for this link there is something wrong is happened, so there is some congested traffic is there. So basically this is all about the use case for alert mechanism. We can again add some extra features. So future scope for this alert mechanism is, so now I am considering the hard-coded value for alerts. So from UI itself, user can give the threshold value. So suppose I want that after the 10 seconds, my jitter value, if it's more than 10 seconds, it should show me the alert. So we can add this threshold value through UI. Second thing is we can show some pie charts which will show the network utilization. So we can then consider certain parameters, and based on that some measures like congestion and bandwidth, we can see that, we can monitor that, and then we can show some pie charts of our network utilization in DLUX. Yeah. So again, through DLUX itself, any network user OpenDaylight user can easily add this traffic flows. So network admin can force this traffic. So network admin can force the traffic to follow that particular paths. So last thing is we can again add the policy, because we have a different features in OpenDaylight. We have a group policy based features. So we can add these policies through our UI itself. So these are the different use cases where we can work on it, and we can start giving these features into the DLUX. So that will help for community also, and we will make the DLUX very dynamic and effective. So these are some references for this presentation. Okay, I will show you one video which will give the summary of what I have talked so far.
Great UI design must have a perfect balance of amazing looks and interactivity with ease of use and simple navigation. UI is abstraction for any product which hides complex backend from end user. Great UI design must have a perfect balance of amazing looks and interactivity with ease of use and simple navigation. Bad design of UI end up with confusion and frustration in new user. DLUX is the UI for OpenDaylight. User can view network topology through DLUX. Let's make OpenDaylight user happy. Let's introduce alert mechanism in OpenDaylight. This feature enabled DLUX user to view normal traffic flow through green color as well as congested or delayed traffic through red color. This feature makes DLUX more dynamic. Thank you for your time. UI is abstract.
Okay, so thank you for your valuable time. So this is what? Basically, DLUX itself has that code. Basically, DLUX itself has Node.js code, so we can use that code itself. So the code is already there. If you gone through the DLUX code, currently they are using a topology REST API. So we can just added this feature inside the topology REST API. So we can monitor that REST API, and we can check the conditions which I have talked. So 0001, and then we can display it to the DLUX. So I don't have that idea if, but majorly these use cases are related to DLUX itself. Thank you for your time.